Today's very important lecture. We're done with all the preliminaries which we needed to do to understand in general what's going on. And now we are getting into the most important stuff, chapters 6, 7, and 8. What we will learn here you definitely will need going forward, and hopefully whatever we did before will help you understand what's happening now. First, though, let's refresh our memory. So what is an argument? What exactly is an argument? What's the definition? Should be in your heart now. Is it a statement? No, it's not a statement. So what is it? It's a group of statements. What's going on with that? Are they just randomly thrown out there?
Supports a conclusion.
Huh?
It's a group of statements that support a conclusion.
Was conclusion is not an argument?
Yeah. Oh, a group of statements, but
One or more of which support the other ones.
yeah.
And then we can call the first ones premise or premises and the second one the conclusion. So it's a group of statements, but what is happening within this group is one or more claims to provide support to the other one. So that's some of the things, like I said, which are foundations you should know by now. Okay, should be at least two statements, one or more claims provide support to the other one. And what kinds of arguments are there? Deductive and inductive, so you can just even work here. So deductive and inductive, what's the difference? If we put deductive here, what is this connection based on in deductive argument? Necessity. Remember necessity. And if we put the inductive arguments there, we don't really need them that much now. We're not going to see them again. But what are they based on? Probability. However, deductive arguments is what we're going to be working with for the rest of this class. They are based on necessity, and remember they can be, what do we call them? Good or bad, but we have better terms, valid or invalid. And what's the difference? This is a very important concept which you should know by now very well. Yeah.
If it's valid, there's no way for the conclusion to be false given the premises are true.
Exactly. Given the premises are true, there's no way for the conclusion to be false. It's like the truth machine. You put truth in, truth comes out. What if you don't put truth in? What if you put falsity in? Then you have no idea what will come out, the whole machine breaks down. But if you put truth in, truth should always come out. If there's any chance whatsoever falsity may still come out, then it is invalid. And there is no middle ground. So that's like basically a function. And we will be working with functions of this sort now. Okay, symbols and translation. First of all, we learned that validity is a function of the form. Remember, whereas with inductive arguments, in order to know whether they are weak or strong, you look at the content. What are they talking about? Here, you don't need content. They could be talking about anything. As long as the form is valid, the argument will be valid. As long as the form is invalid, it will be invalid. So we can extract the form and work with the form itself. And that is enough for us to understand validity and to work with validity. But to do so easily, we need certain rules. And this is what we're going to start learning now. Symbols and translation, how do you translate them into a different language, which is actually, we can call, the book doesn't mention it, but you can call it language 1, L1. So that would be propositional centennial logic. And that language has its own rules, which we will learn, and then we will be working just with the forms by themselves using these rules. So we will learn logical operators. Logical operators just replace words. instead of using words in English language, we'll be using logical operators, making our job much easier, because when you inspect an argument, remember how much confusion all these words create. Could mean this, could mean that. Of course, there's still a problem, how do you translate it correctly? And this is what we're going to be working on at the beginning. But eventually, the further on you go, you will see the less of an English language you would need and more of these actual symbols, which becomes a lot easier to work with. Okay, and also, instead of using terms now, we'll be using whole propositions. Remember, proposition for us is the same thing as a statement, so you can say a statement, but really there is a small difference between statement and a proposition. Proposition is just a meaning, whatever has the meaning. It's not in any particular language. But for our purposes, it doesn't matter. At this point, you can say statements because Hurley Watson calls them statements, so fair enough. Statements. Statements will be represented by letters, and these letters combined by means of operators. To form one or more complex symbolic representations. So let's take a look first of all at simple statements. This is a simple statement. Remember what a statement is. It's a sentence which is true or false. These are some examples. Fast foods tend to be unhealthy. Is it true or false? True. We can replace this whole thing with just one letter. For example, capital letter F. We can say from now on F stands for fast foods tend to be unhealthy. Another example, James Joyce wrote Ulysses. You can also replace it with just one letter. Let's say J. Is it true or false? Anybody took literature?
It's false.
Nobody took literature. It's true. James Joyce, that's his famous novel, Ulysses. Groundbreaking novel, beginning of 20th century. It's not the same thing as Odyssey, written by Homer in ancient Greece. Ulysses, you can Google it. Anyway, that's not literature class, so it doesn't matter much. Parakeets are colorful birds. Another simple statement. We can just use letter P here. Is it true? Yes. The bluefin tuna is threatened with extinction. Once again, a simple statement. You may not know this one. It's not really common knowledge. It actually is true. We can use letter B, right? Bluefin tuna. The letters themselves don't matter, but the capital letters stand for specific statements like this. So, uppercase letters always stand for specific statements. Whichever letter you choose doesn't matter, but if you chose letter to call your statement with this letter, you have to be consistent and keep on calling it the same thing. Lowercase letters have different purposes, and actually, if you take advanced classes, instead of lowercase letters, they frequently use Greek alphabet. We will see it a little bit just so that you would not be completely horrified, but that's not standing for any specific proposition. It's just a general formula. Okay. So, in addition to simple statements, we have compound statements. Compound statements have something other than just simple statement. Let's take a look at some examples here. It is not the case that Al-Qaeda is a humanitarian organization. So, simple statement here would be Al-Qaeda is a humanitarian organization. For example, you can call it A. Now note that they are telling you something different. What are they telling you? That it's not the case. So for now you can just use language and say it is not the case that A. Right? A being Al-Qaeda is a humanitarian organization. Let's look at another example. Diane Reeves sings jazz and Christina Aguilera sings pop. There are two simple statements here. Diane Reeves sings jazz is D, right? And Christina Aguilera sings pop is C. Either one of them is true or false. By the way, I don't know if you know who Diane Reeves is, but that is true. She sings jazz. How about Christina Aguilera sings pop? Is that true? Anybody knows Christina Aguilera?
Yes.
Or was it too long ago?
That is true.
Yeah, it is true. She does. She got a very popular hit, Genie in the Bottle. That was like many years ago. But she's still there. Anyway, for our purposes, again, whether it's true or not doesn't matter as much. But just to remind you that they do have true value. It's either true or false. Between them, we have the word and. Another example is either people get serious about conservation or energy prices will skyrocket. We saw these kinds of statements. Where did we see them?
The detective, is that like
Disjunctive syllogisms. Disjunctive syllogism starts with disjunction like this. Either that, this, or that. So people getting serious about conservation we can call P, energy prices skyrocketing E, and they are connected with either this or that. Then we have our good old friend conditional statement. If nations spurn international law, so we call it N, our antecedent, then future wars are guaranteed. We can call it F. And again, we have if-then situation. If this, then this. And finally, Broncos will win if and only if they run the ball. You see here, you actually again have two simple statements. Broncos will win, we can call it B, and Broncos running the ball, which is different statement, we can call it R. And they are connected that B if and only if R. Different from just if. If you think about it, it has different meaning. So this is what we just discovered. I've written it down over there. We can see it here too. So what we are going to do is to replace these extra words with symbols. That would make our job much easier. So this is the symbols we'll be using. This is what Shirley Watson uses. First of all, for it is not the case that, we will be using tilde. That is this wiggly line. Put it here. So tilde A would just mean it's not the case that A. You also can use it to replace just not A. It's a negation. The second situation, and, we will be replacing with a dot. Nice big dot. D dot C would just mean D and C. The third one, or, either or, can be replaced by wedge. So P wedge E would mean P or E. Now just a couple of rules when you're writing it down so you would not be confused. First of all, for the dot, make sure it is kind of a thicker than just normal dot and somewhere in the middle, not on the bottom, because otherwise you'll be confusing it with just a period. For the wedge, I would advise to make it about half the size of the letter, because if you make it too big, it would look like you're writing PVE. Right? And then our good old friend, conditional statement, if then will be replaced with the horseshoe. So and horseshoe F would mean if and then F. Finally, for the last relation called equivalence, we will be using the triple bar. If and only B, if and only if R, triple bar between. Okay. Now, to make it a little bit more confusing, but hopefully not too much, this is the way Shirley Watson does it. But that's not the only way to do it, and I want you guys to be familiar with other ways, because you actually will see that in different logic classes they may be using different symbols. So let's take a look. This is the table for the same symbols used in a variety of different ways, right? So conjunction, which here is the dot, frequently used with this. It's like wedge, only the other way around. It means they're exactly the same thing. And note that what you actually use in there doesn't matter as much as understanding the rules. And the rules are all the same. It's just the symbols can be different. You can also even sometimes see these ways, like the sign and the period, depending on the logic book. Now, it is not the case we're using tilde, but you can sometimes also have just like a minus sign or like this sign. You will see it in different logic books. That just means exactly the same thing. Now, horseshoe. Instead of horseshoe, I actually prefer an arrow. And you will see me using it sometimes. Because I think it is more intuitive. And many logic books actually use arrow instead of the horseshoe. Again, the same thing. It shows you direction. Direction is important here. And finally, triple bar for this relation frequently is just two-way arrow, which again is a little bit more intuitive. So that is just different ways to express exactly the same thing, right? You can use it like this, or these other variations. It shows you pretty much all the possible other variations you may see in other books. We're working with Hurley-Watson now, so we will be using this one. Tilde, dot, wedge, horseshoe, triple box. Although, like I said, I still, on slides, I even use an arrow. Arrow is a little bit better, I think, than horseshoe. But they all mean the same thing. They are just different ways to express these relations. And relations is the important part, not how you express them. It's like, when you write in English, you can use different ways to write letters. Other people can use slightly different way than you. The way they teach you in school, probably one way, but then later when you write yourself, you can develop slightly different habits in terms of what letters you're using. Same thing here. It doesn't really matter that much. Just be aware of this. Okay, so back to Hurley-Watson. This is the way Hurley-Watson does it. So this is how it is in the homework. Tilde, dot, wedge, horseshoe, triple dot. First relation, called negation. When you see tilde, that basically just says it's not the case or not. Second relation, conjunction. It connects two statements. Third one, disjunction. It says either this one or that one. Then conditional statements, we saw them before. We'll see them again and again. And the last one is called actually biconditional, which is why they use this kind of arrow in both ways. We will see why it is biconditional. Let's start with negation. There are many different ways to say it in language. So when you translate, you should be aware of them. For example, you can say Rolex does not make computers. So if R is Rolex makes computers, adding negation means it's not the case. Rolex does not make computers. So you can also say it is not the case that Rolex makes computers. And you can say it is false that Rolex makes computers, which again would all be expressed with the tilde. Tilde is always in front of the proposition. You never connect two propositions with a tilde the way you do with other operators. So if you try to write something like this is a mistake. You cannot do this. Do not connect two propositions with a tilde. This is meaningless. It's not allowed. This is all negations. Why are they all negations? Because the main operator is tilde. How do we know what is a main operator? It's a little bit like in math. It's actually, the rules are very simple. So Hurley-Watson makes it especially easy. It's not always the case that you will see all these brackets and parentheses. Sometimes when it is rather obvious, they don't put it. They don't Hurley-Watson does not explain certain rules, but there are certain rules in addition to the rules Hurley-Watson goes over, which help to understand when do you need parentheses or not. Hurley-Watson is a little bit easier, really. So in Hurley-Watson, anytime you see more than one operator, you will see parentheses or brackets, making sure you understand what's the main operator. And the rules, like I said, are fairly simple. If you have anything other than tilde, that will be your main operator because anything beats tilde. But if it's just tilde outside all the brackets and parentheses, or if it is just tilde, then it is tilde. So let's see some examples so you could understand. Let's look at the first statement. Right, you go outside all brackets and parentheses. What operator do you have here? Dot. So that's your main operator. Done. How about here? You go outside all brackets and parentheses. What do you have? Tilde. That's tilde. Done. Here, if you go outside all brackets and parentheses, what do you have?
Horseshoe.
Horseshoe and tilde.
Yeah.
Right? But horseshoe beats tilde. Anything beats tilde. So as long as you have something and tilde, whatever else you have will be tilde. So horseshoe will be the main operator.
Mm-hmm.
I don't know if I should make it more complicated than this right now. So let's just leave it at that. Now conjunction. Remember, it's a dot, right? Easiest way to understand it is the word and. But in language, we use a whole bunch of other words which also are translated as and, as dot. This is a bit of a simplification. In language, you have different shades of meaning, but we are simplifying it. So for our purposes, first of all, the word and is obviously a dot. So Tiffany sells jewelry and Gucci sells cologne. That would be translated as T. Tiffany sells jewelry dot G. Okay. How about but? Tiffany sells jewelry, but Gucci sells cologne. Same thing, you are using a dot. But for our purposes means exactly the same thing as and. How about however? Tiffany sells jewelry, however Gucci sells cologne. Again, a dot. Again, it's just the same thing as and. In some cases, but not always, you can also have the shortcut. Tiffany and Banbridge sells jewelry. Now that would be T and B because you have two equivalent statements here. Tiffany sells jewelry and Banbridge sells jewelry. Right? This is what we call inclusive conjunction. Inclusive conjunction means that it is equivalent to these two statements. But it's not always the case. In language, some conjunctions are exclusive. What would be exclusive conjunction? Mary and Louise are friends. Is it equivalent to Mary is a friend and Louise is a friend? No. You can see you cannot translate it in the same way. So you have to be aware of this a little bit. Anytime you have this kind of a shortcut like Mary and Louise are friends, you have to ask yourself, is it equivalent to Mary is a friend and Louise is a friend? If it is, you can just use a dot. If not, it gets a little more complicated. Don't worry about it now. There's a way to translate it too, but you need a little bit more symbols. This is all examples of conjunctions. Why? Because dot is a main operator in each one of them, right? If you look here, well, we don't have any parentheses or brackets, but we have a dot and the tilde, and anything beats tilde, so it's a dot. Here we have some parentheses. If you go outside of all of them, you will have a dot and a tilde, and again, anything beats tilde, so it's a dot. Here, you have parentheses and brackets. So once you go outside all the brackets, you're only going to have a dot. Can you see that? So if you pay careful attention, you will see that this is a conjunction. It has more operators, but it still is called a conjunction because whatever your main operator is, that's what it is. Yeah?
For the first one, where you have the conjunction and the negation, how would that translate?
Well, don't worry about it right now. You will see examples. Like first of all, you have to translate K and you have to translate L.
Yeah,
You have to know what they are.
Well, just like a simplification would be like K and L are not, or
K and not L.
K and not L. Okay.
Well, this is not really translation, but this is like how you read it.
Yeah, just like a
Yeah.
yeah.
Okay. Disjunction. Let's look at disjunctions. Again, different words in the English language could express the same thing. The easiest way to think about it as or, right? That's this which. So Aspen allows snowboards or Telluride does. So that would be A or T. Either Aspen allows snowboards or Telluride does. Same thing exactly, right? They add in the word either, but the meaning is the same. Also, Aspen allows snowboards unless Telluride does. We translate it with a wedge. And unless Aspen allows snowboards, Telluride does, again a wedge. Translating from language can be complicated. There are many different little rules. We will talk about them throughout the whole class today. Try not to get too confused. You need to do homework on this. And in some cases, it may still be a little bit confusing. Really, in the future, it's not going to be that important because we will just work with them without much translation. But nonetheless, you should remember that we are translating from English to this propositional language. So that is sometimes a little tricky. So this is all disjunctions, again, because they all have wedge as a main operator. Here you have two tildes and a wedge. Well, still, everything beats tilde, so it's a wedge, right? Here, if you go outside all the parentheses, it's a wedge. And here, if you go outside all parentheses, it's two tildes and a wedge. And it is, of course, again, a wedge, because everything beats tilde. Keep that in mind. Now, logical equivalency. Disjunction and conjunctions are logically equivalent, which means we don't care what's on the left side, what's on the right side. T or A is equivalent to A or T. T and A is equivalent to A and T. You can't do it to horseshoe, to conditional statements, because it matters what's on the left, what's on the right. That is, we call this implication, right? And here we're using the horseshoe. If-then statements. There are, again, different ways in language. We saw it a couple of times already. So the easiest way, if you have the straightforward if this, if P in this case, then N. So you just put P, horseshoe, N. Right? But there are several other ways to express the same thing. Remember, we saw this before. If you have, let me use different letters. Let's say you have P if N. Just the if between them. Well, when you translate it, this actually becomes your antecedent because it follows N. So N should be here, and I'm using the P here. So the rule to remember is, if you have just in the middle of your statement, you have to flip them around. Whatever was on the left side becomes on the right side. Whatever was on the right side becomes on the left side. Remember, I mentioned it when we talked about conditional statements. To make it slightly more complicated, if you have P only if N, you don't flip it around, then P is here, N is here. Right, so this is the three situations to remember. If, then, straightforward, P on the left, N on the right. If, flip them. Only if, don't flip them. There are several other ways to say the same thing. So kernel, Katz, and Ullman, provided that. Well, provided that is the same as if. So you again need to flip them around. Kernel, Katz, and Ullman, provided that Brown does. B on the left, C on the right. Similarly, Cornell cuts enrollment on condition that Brown does. Same thing that B goes on the left, C on the right. Brown cut enrollment implies that Cornell does, B on the left, C on the right. So this is three situations you're not going to see as often as these three, but keep them in mind. In case if you're worried about remembering all this, well, at least next homework, next exam will be on internet, so you can actually look it up if you don't know. It'll be pretty much open note.
Oh, okay.
Yeah, so we're not going to do it on a Scantron in a classroom. Same for homework, of course. If you ever forget, go back to your slides or your notes or your book, take a look. Because I understand there may be many different situations, but you still need to be aware of them at the very least. So let's say this is your condition statement. This part would be sufficient condition for this. For antecedent sufficient, for consequent, consequent necessary for your antecedent, right? So we can replace this with n because this one with s, sufficient. This one with n. Now you will also have an easier way to remember that. In case if you're wondering, what's my sufficient condition, what's my necessary, you can use this simple trick. No. Sun. Right? The word sun. It's the same thing except you just turned your horseshoe sideways. So just like the word sun, your left side, your first letter is sufficient condition, the right side is necessary. Why do you need it? Well, you will see in a second. You can have situation like this. Hilton's opening a new hotel is sufficient condition for Marriott doing so. How do you translate it? Well, since Hilton is sufficient condition, where does it go? On the left side. And Marriott opening is on the right side. And there is a horseshoe between them. But let's say you are told Hilton opening a new hotel is necessary condition for Marriott doing so. What do you do now? Well, since it's necessary, where does it go? In the second position. And whatever is after that, Marriott is on the first position. Always remember that M doesn't stand for Marriott and H doesn't stand for Hilton. What does the M stand for? Marriott opening a new hotel. And H stands for Hilton opening a new hotel. So don't get confused. We can't just use these capital letters. There's always a statement. We cannot put them for just name of the hotel or something. Okay, and now the last operation. It's actually more interesting and a little bit more complex. Triple bar, this if and only if. It's called equivalence. JFK tightening security if and only if O'Hare does. So JFK tightening security J, O'Hare tightening security O, triple bar between them. That is JFK tightening if and only if. It's different from just if, different from only if. It is if and only if. Or JFK tightening security is sufficient and necessary condition for O'Hare doing so. Why do they translate it the same way? Because this is the thing with triple bar. It is actually two statements. It is J if J then O, and if O then J. That's the full translation. So it is sufficient condition for J sufficient for O, O necessary for J, and O sufficient for J, J necessary for O. So they're both sufficient and necessary for each other. Right? So it's like the strongest connection between two statements. Which is also why if you're using an arrow, you can translate them this way. J, arrow both ways. Right? But we will see later that there are different ways to have these longer statements and there are different rules applying to them. So yeah, like I said, this is the full translation. if you understand what they are doing here, you understand this. We will see more ways to do it later. This is all biconditional statements. Again, why they call it biconditional? Because they condition for each other, right? Biconditional statements. This one, main operator triple bar. Why? Because there's triple bar and tilde, and everything beats tilde. Here you have two tildes and triple bar outside all the parentheses. So again, everything beats tilde. And here you have just a triple bar outside the brackets. Everything else is in brackets, so that's the main operator. Now, with more than two letters, like I said, you actually you're not always supposed to do it, but for simplicity, the way they do it in Hurley-Watson, you will always see parentheses or brackets showing you clearly what is the main operator, so you would not be confused. That is the way to slightly simplify the story. Pay special attention to punctuation, location of the words either, or, and both. So when you yourself translate something, how do you know where to put the parentheses? Well, there's a whole bunch of rules about that. Let's take a look at them. So first thing to note is the commas. If you see a comma, that can tell you where those parentheses go. First example, Prozac relieves depression. Prozac relieves depression, P, right? Allegra combats allergies, A. Zucker lowers cholesterol. So they say Allegra, in the first place you have and, right? So you put a dot. In the second place you have a wedge, or. So this is the way you translate it. But since you have two operators, you have to show which one is the main one. How do you know? Well, look at the parentheses. Look at the comma. You put a yellow dot on it, right? So the comma shows you where one of the parentheses will go. Since they have a comma here, you put one parenthesis here. Well, it obviously wouldn't make any sense to put two parentheses here. So that way. Another example is Prozac relieves depression, comma, and Allegra combats allergies or Zucker lowers cholesterol. Now, when you have this, since your comma is after here, you do need to put your parentheses. Okay, sometimes you may not have a comma. So what do you do then? The word either helps you too. Either Prozac relieves depression and Allegra combats allergies. Either shows that there should be a parenthesis, so it goes like this. On the other hand, Prozac relieves depression and either Allegra combats allergies or Zucker lowers cholesterol. Now the word either is here, so you have to put the parenthesis like this. Similar with the word both. The word both is just like the word either, shows that you need to put a parenthesis wherever the word both is. Prozac relieves depression of both Allegra combats allergies and Zucker lowers cholesterol. So these both, they are in parentheses. Now how about this? Prozac relieves depression and Allegra or Zucker lowers cholesterol. Well, one way to figure out, they clearly are putting Allegra and Zucker together, right? You can see, because instead of saying Allegra combats cholesterol or Zucker lowers cholesterol, they say Allegra or Zucker. So that is in parentheses. How about if you have conditional within condition? If Merck changes its logo, then if Schweitzer increases sales, then Lilly will reorganize. Well, here, whatever follows then is whole other conditional statement, right? So it has to be in parentheses. But if Merck changing its logo implies that Schweitzer increases sales, then Lilly will reorganize. Now, whatever is before then looks like whole other conditional statement, so that one is in parentheses. Okay, few more things. Not as the function of either or both. what is happening if you have not either A or B, translated negation, A or B in parentheses. But either not A or not B, you see they're putting not next to each one of them, so you actually have to use tilde next to each one of them. Similarly, not both A and B, you're not outside of parentheses. The word both shows that they are in parentheses. Both not A and not B, here you have to put negations next to A and next to B. Okay, something else which actually they are not using in Hurley-Watson, but I think you should know at this point. So we have what is known as well-formed formulas. Well-formed formulas are the ones which follow the rules we just described. It's usually just they write it in a book as WFF, and we pronounce it as WOOF. Well-formed formula just means they follow the rules, right? So, for example, there is a cat on a porch in the English language is a well-formed formula because it follows the rules of English grammar. On the other hand, porch is on the is cat as there is not a well-formed formula because it doesn't follow the rules of grammar. Similarly with this new language, like I said, it's basically a new language. If it doesn't follow the rules, then that would be not a well-formed formula. Here, why is it not well-formed formula? Well, they are putting two operators between two letters. Right? That's not allowed. So that's not a well-formed formula. Similarly here, A and B, and then O or C, and they put in parentheses here. Not a well-formed formula. Similarly here, negation, wedge, and then B. That's not following the rules, so no, not well-formed formula. Similarly here, well, actually that's one thing. So the whole thing is completely wrong. If you're not following the rules, that's not a well-formed formula. So just some idea statements cannot be combined without an operator occurring between them. So you can't just write AB. If you have two statements, you have to put an operator, and it cannot be just a tilde. Remember, it has to be one of the other operators. You can't put it like this. This is not math. You don't presume that there is something here. You can't put something like this. On the other hand, this would be well-formed formulas. A horseshoe B, A or not B, A and if B, B if and only if C. This is well-formed formulas. And similarly with tildes, tilde goes before your statement, right? You cannot go after the statement, cannot connect to statements, cannot go after the expression in parentheses. This is not well-formed formulas, but these ones are. You can have two tildes. That's actually the equivalent of no tilde. But actually what a tilde does, it changes the true value to the opposite. So if you change true value to the opposite twice, you end up with the same true value. It's like flipping the coin twice. Okay, we will see these details a little bit later, but for now the idea is clear, right? Not well-formed formulas if you do not follow the rules. If you have an expression which is not correctly written, it's not a well-formed formula. Just few other ones. Tilde cannot immediately precede any other operator. Well, obviously. So tilde dot A, not a well-formed formula. Tilde wedge B, not a well-formed formula. A dot, wedge, horseshoe, or triple bar must go immediately between the statements. So not well-formed formula, well-formed formula. And parentheses, brackets, and braces must be inserted to prevent ambiguity, which, like I said, not always really the case, but this is the way Hurley-Watson does it. So this would be not well-formed formulas, even though, strictly speaking, this is well-formed formula. But, okay, let's say it's not. And this is also not. This is actually the way it is supposed to be according to Hurley-Watson.